In this video, I'm going to go over a free fall problem. So the problem is, my students played a prank on me last year and dropped a water balloon from the band tower while I was standing underneath. If the balloon traveled 3.5 meters, how fast was it going when it hit me on the head? So the moment, I'm going to use a highlighter here, the moment we see that something is dropped, the moment you see that, there's two things you need to write down. Your acceleration, because it's dropped, is a negative 9.8 meters per second squared. And because it was dropped, your initial velocity is 0, because, the kid that was playing this prank on me was holding the balloon until it was positioned perfectly above my head, which means that your initial velocity was 0 because they were holding it. And then they let it fall. And the other piece of information that it gives you is that it traveled 3.5 meters. That 3.5 meters, you need to be able to figure out that meters measures distance, so that's going to be the distance that it travels. And because this is a free fall problem, it's traveling straight down. So I'm just going to draw a picture, like here's the band tower, here's the little student that decided to drop this balloon on my head, and here I am just standing nicely minding my own business, and this balloon drops straight down, and that distance is 3.5 meters. Now, this is all the information that it's given, so then you have to figure out what you're looking for. We're looking for how fast. How fast is talking about speed or velocity. So what I'm going to be looking for is our V final. That's my unknown. If you're not listing out your givens and your unknown, it becomes very difficult. Now, I'm going to pause the video and I'm going to write down the 4 equations that we're going to use, and then we'll talk about those 4 equations. Alright, so over here are the 4 equations. They're on your formula chart, you're given to them, but here they are. You are given them. If I'm looking for V final, then obviously I have to pick an equation that has V final in it. So I'm just going to kind of dissect all of these equations, and we can narrow down which one we're going to be using. The first thing I'm going to do is, if I'm looking for VF, I'm going to look at the equations and make sure VF is there. So VF is in this first one right here. It's in this second one. It is not in this third one whatsoever. So I'm going to go ahead and just cross that one off, because it doesn't even have what I'm looking for, therefore I don't need it. And this last one has VF. Now, we also have A. So I'm going to look, and I'm going to underline everything that has A. I'm going to ignore that third one because it's already gone. And then we have VI. I'm going to make that one yellow. And we have D. Okay, I'm going to make that one green. So now this kind of, I've color-coded it. I have underlined what I have. The one variable that is in this first equation right here that we don't have is T. Nowhere in this problem am I given a time, and I'm not looking for time. So even though this has VF, I don't have T, which means I can't use this equation to solve for VF because I don't have all the variables. Same for this one, the second one. It has T in it. I can't use this. That would be 2 that I don't know a number for, and I can't solve it algebraically. We've already crossed off the third one. That means this fourth one is the one that I need, because I want VF, I have VI, I have A, and I have D. So now I can plug these variables in, and I can solve for VF. So when we do this, we get that VF squared equals 0 squared plus 2 times a negative 9.8, and my distance is a negative 3.5. So I forget every time when I'm listing out my variables to make this distance a negative, but it is a negative because it's traveling in the negative y direction. So this actually helps when you're solving these problems, because if you forget that 3.5 is negative, then you try to take the square root of a negative number, and we don't do that here in this class. Okay, so now I'm going to simplify. I have VF, My 0 squared, guys, that's just 0, so let's just completely ignore it. 2 times negative 9.8 times negative 3.5 is 68.6. But I want VF. I don't want VF squared. So to get rid of that squared, I have to take the square root of both sides. When you do that, you get VF equals 8.28. Because it's velocity, it's meters per second. And because it is going in the downwards direction, the negative y, we show that by either writing 8.28 meters per second down, or we say negative 8.2 meters per second. And that's how you solve a free-fall problem. So just to recap, you have to read the question, you have to write down all of your givens. Remember, these first two you have to know. Then you're going to be given some other piece of information you have to write down, and then you have to figure out what you're looking for. You then need to go through your 4 equations to kind of figure out which one works. Which one do you have all the variables except for the one you're looking for? And use that one. And then using algebra, you rearrange.